1942, Shortland Islands, Solomon Sea. The tropical dawn breaks heavy and wet. Lieutenant Commander Fujimoto Kenji stands at the edge of a makeshift airstrip carved from coral and red clay, watching smoke rise from the distant horizon. His engineering corps has just returned from photographing the American airfield at Guadalcanal through reconnaissance passes, craters everywhere, runways shattered like broken teeth. He carries a leather-bound notebook filled with precise calculations. Tonnage of bombs dropped, estimated cubic meters of displaced earth, projected repair timelines based on Imperial Army engineering standards. By his figures, that airfield should remain inoperable for 6 to 8 weeks minimum. He lights a cigarette, satisfied. The mathematics are unforgiving. 6 weeks means 6 weeks of American air power grounded, 6 weeks of Japanese supply lines flowing uncontested, 6 weeks of strategic breathing room in the South Pacific. He has seen what it takes to rebuild damaged infrastructure across Manchuria, across China, across the conquered territories. The numbers never lie. But 48 hours later, reconnaissance pilots return with photographs that make no sense. The American airfield is operational, fully operational. Transport planes taxiing on smooth runway surfaces where craters gaped like wounds just 2 days before. Fujimoto studies the images under lamplight until his eyes burn, checking them against his calculations again and again, searching for photographic error or misidentification. There is none. The Americans have performed what his engineering training tells him is impossible. They have bent physics itself, or they possess some industrial sorcery that Japanese military doctrine has failed to account for entirely. The war in the Pacific had been proceeding according to prediction. Japanese forces swept through European colonial holdings with methodical efficiency. Hong Kong, Singapore, the Philippines, the Dutch East Indies falling like dominoes before a carefully orchestrated offensive. American forces retreated, regrouped, retreated again. But something else was happening simultaneously, something the architects of Japanese expansion had miscalculated with fatal precision. They had accounted for American industrial capacity in their war planning, yes, but they had calibrated their estimates based on peacetime production figures and Depression-era economic doldrums. They had assumed that American society, soft with comfort and divided by democratic squabbling, would require years to mobilize its industrial base toward total war. They had assumed American soldiers, raised on luxury and individualism, would lack the spiritual discipline for sustained combat in harsh tropical conditions. They had assumed that American engineers, trained in profit-driven civilian enterprises rather than martial efficiency, would approach military construction with the same languid pace that characterized Western commercialism. These assumptions were not paranoid fantasies or racist propaganda, though they were certainly stained by both. They emerged from careful intelligence analysis, from observation of American political paralysis during the 1930s, from documented reports of labor strikes and unemployment lines and isolationist movements. Japanese military planners had watched America struggle through economic collapse, while Japan built its greater East Asia co-prosperity sphere. They had seen the photographs of Hoovervilles and breadlines. They had read the American newspapers filled with arguments about staying out of foreign wars. The conclusion seemed mathematically sound. America was a sleeping giant, yes, but a giant suffering from industrial arthritis and democratic indecision. By the time it fully woke, Japanese defensive perimeters would be impregnable. Lieutenant Commander Fujimoto had graduated top of his class from the Imperial Japanese Naval Academy. He had studied civil engineering at Tokyo Imperial University. He had overseen the construction of 3 military airfields in occupied China, had calculated load-bearing requirements for bridges across the Yangtze, had mastered the physics of rapid military infrastructure deployment. When he examined those first reconnaissance photographs of damaged American airfields in early 1942, He applied the same rigorous methodology he had employed throughout his career. He knew precisely how long it took to fill a bomb crater, the surveying time, the equipment mobilization, the material transport, the compaction process, the surface treatment. He had done it himself dozens of times. An airfield struck by concentrated bombing required weeks of systematic repair before it could safely handle the stresses of heavy aircraft operations. This was not ideology or hope. This was engineering fact, proven across multiple theaters of war. But the Americans were not repairing their airfields according to any engineering manual Fujimoto had ever studied. They were not even repairing them according to physical laws as he understood them. The first time might have been luck or misidentification. The second time demanded investigation. By the fourth time, by the eighth time, by the dozenth time watching American airfields sustain heavy damage and resume full operations within days or even hours, Fujimoto began to feel something he had never experienced in his military career. A crawling uncertainty about the fundamental assumptions underlying his training. If American engineering capabilities exceeded Japanese estimates by this magnitude, what else had been miscalculated? What other comfortable certainties were about to dissolve under the harsh light of empirical observation? The secret was not supernatural. It was industrial. It was organizational. It was cultural. It was the marriage of American mass production techniques with military necessity, catalyzed by the shock of Pearl Harbor into something unprecedented in human history. The United States military had mobilized not just factories, but entire systems of thought, civilian engineering firms, university research programs, private construction companies, labor unions, equipment manufacturers, into an integrated machine designed for one purpose: building and rebuilding faster than the enemy could destroy. They had industrialized the very concept of infrastructure repair, transforming it from craftsmanship into assembly line process. The tool that Fujimoto's calculations could not account for was already being manufactured in vast numbers across the American mainland. The Marston mat, officially designated as pierced steel planking. 10 feet long, 15 inches wide, corrugated steel panels pierced with holes to reduce weight and allow drainage, each piece interlocking with the next through simple hooks and slots that required no welding, no cement, no specialized installation expertise. A single panel weighed 66 pounds, heavy enough to be durable, light enough for 2 men to carry. But the genius was not in the individual panel. The genius was in the system. These panels were stamped out by American steel mills at rates Japanese intelligence had not imagined possible. Tens of thousands per month, then hundreds of thousands, eventually millions, each one identical and interchangeable, shipped across the Pacific in cargo holds alongside ammunition and rations and medical supplies. When bombs tore craters in an American airfield, Seabees, the Naval Construction Battalions, did not approach repair as a careful engineering restoration project. They approached it as an assembly problem. Bulldozers filled craters with whatever material was immediately available: crushed coral, compacted earth, broken concrete, even rubble from destroyed buildings. The fill did not need to be perfectly compacted or carefully graded to exacting specifications. It just needed to be roughly level. Then the Marston mats rolled out across the surface like industrial carpet, panels hooking together with mechanical precision, creating an instant runway surface capable of handling the weight and stress of fully loaded bombers. What would take Japanese engineering corps weeks of careful surveying and material preparation and compaction testing, American construction battalions completed in hours through brute force application of prefabricated materials and overwhelming manpower. But even the Marston mats were just symptoms of a deeper industrial philosophy. American engineers were not better trained than their Japanese counterparts. Many were civilians who had been building highways and bridges and sewage systems just months before being handed military commissions. What they possessed was not superior individual skill, but superior systems integration. The U.S. military had adopted assembly line thinking, pioneered by Henry Ford and Frederick Taylor, and applied it to every aspect of military logistics. Airfield repair kits arrived prepackaged with every tool, every spare part, every component needed for rapid deployment. Instruction manuals were written for maximum clarity and minimum expertise. Paint-by-numbers as procedures that allowed relatively inexperienced personnel to execute complex engineering tasks through rigid adherence to standardized processes. Equipment was designed for interchangeability. Bulldozers with swappable blade attachments, trucks with modular cargo configurations, generators with standardized voltage outputs that could power any American-made tool. Fujimoto began collecting reports from across the Pacific Theater, assembling his own intelligence file on American engineering capabilities. The pattern repeated with disturbing consistency. Henderson Field on Guadalcanal bombed repeatedly, operational within hours each time. Airstrips in New Guinea struck by Japanese bombers, back in service before the attack aircraft even returned to base. Forward airfields in the Solomons that Japanese forces had spent weeks systematically destroying, rebuilt to operational status in 72-hour marathons of around-the-clock labor. The numbers made no sense according to Japanese engineering doctrine, but they were undeniable. American construction battalions were achieving repair speeds that violated every assumption about infrastructure development timelines. The symbolic weight of these rapid repairs extended far beyond tactical inconvenience. Japanese military strategy in the Pacific relied on destroying American forward airfields faster than they could be rebuilt, denying American air power the bases it needed for offensive operations. The entire defensive perimeter concept, holding island chains at maximum distance from the home islands, depended on keeping American air assets pushed back beyond effective striking range. But if airfields could be repaired faster than they could be permanently disabled, if every bombing raid represented merely a temporary inconvenience rather than a lasting strategic gain, then the entire calculus of attrition warfare shifted dramatically. The Japanese military found itself trapped in a Sisyphean cycle, bombing airfields that reappeared like mushrooms after rain, expending precious aviation fuel and irreplaceable pilots, and limited bomb stocks on targets that refused to stay destroyed. The food came later, but it carried the same industrial message wrapped in different packaging. When American forces captured Japanese-held islands, they brought with them not just weapons and ammunition, but infrastructure for living. Prefabricated mess halls, refrigeration units, field bakeries capable of producing thousands of fresh bread loaves daily, canned goods in varieties Japanese soldiers could scarcely imagine. Captive Japanese engineers watched in disbelief as American Seabees constructed complete base facilities, barracks, showers, recreational areas, paved roads, electric lighting, in timeframes that seemed hallucinatory. What the Imperial Japanese Army considered luxuries reserved for permanent installations, the Americans treated as basic field infrastructure, standard equipment for any forward position expected to operate for more than a few weeks. Fujimoto read the interrogation reports of captured American engineers with professional fascination. They spoke casually of standard operating procedures and prefab construction modules and heavy equipment mobility, as if these concepts were universal rather than revolutionary. They described supply chains with multiple redundancies, where critical equipment failures could be remedied within days through replacement shipments from distant warehouses. They mentioned repair manuals written for 6th grade reading levels, so that any soldier could perform basic maintenance on complex machinery. They referenced training programs that turned civilian construction workers into military engineers in 8-week compressed courses. Every detail reinforced the same fundamental reality. The Americans had industrialized not just manufacturing, but the entire concept of military logistics, creating systems that prioritize speed and standardization over craftsmanship and specialization. The moment of ideological fracture came gradually for Fujimoto, accumulating through dozens of small observations rather than one dramatic revelation. He began to notice how American prisoners, even in captivity, maintained a certain casual confidence about eventual victory that Japanese soldiers found incomprehensible. These men had been defeated in battle, captured, stripped of weapons and dignity, yet they spoke about American industrial capacity with the calm certainty of men describing physics constants. "We can build planes faster than you can shoot them down," one captured pilot told his interrogators matter-of-factly. "You sank 4 carriers at Midway. We'll have 6 new ones built by next year. Your economy is running on fumes. Ours is just getting warmed up." The interrogators filed these statements as enemy propaganda, psychological warfare tactics designed to demoralize Japanese forces. But Fujimoto read them and calculated and found the mathematics terrifyingly plausible. By late 1942, reconnaissance flights over American-occupied islands revealed construction projects that defied military logic as Japanese commanders understood it. The Americans were building not just functional airfields but comfortable ones, with permanent structures rather than temporary shelters, with paved roads rather than dirt tracks, with extensive logistics infrastructure that seemed absurdly over-engineered for temporary military positions. Japanese intelligence analysts interpreted this as strategic incompetence, evidence of American wastefulness and lack of martial discipline. Why invest resources in creature comforts when the same materials could build additional fortifications or manufacture more weapons? But Fujimoto saw something different in those reconnaissance photographs. He saw an industrial civilization so vastly productive that it could afford to build both fortifications and comforts simultaneously, that treated infrastructure abundance as a normal condition rather than a precious luxury to be rationed. The Pacific War became, in essence, a contest between two fundamentally different approaches to military engineering and logistics. The Japanese approach emphasized efficiency and austerity. Do more with less, extract maximum performance from limited resources, accept sacrifice as the price of strategic necessity. Every gallon of fuel, every pound of steel, every bag of cement had to be carefully allocated and tracked and justified. Japanese engineers prided themselves on achieving results with minimal material inputs, on finding creative solutions to resource constraints, on building functional infrastructure from whatever materials were locally available. This was not just military doctrine but cultural philosophy, rooted in centuries of Japanese island nation resource management, and refined through decades of industrialization, without abundant raw materials. The American approach was almost the inverse: solve problems through overwhelming material abundance rather than clever resource management. If building an airfield required 10,000 tons of steel matting, ship 10,000 tons of steel matting plus another 10,000 tons for backup. If fuel supply might become constrained, establish multiple redundant supply lines with excess capacity. If repair speed was limited by available labor, assign triple the estimated workforce and run shifts around the clock. This was not wasteful excess, but calculated redundancy, systematic over-engineering, designed to eliminate supply bottlenecks and equipment failures as limiting factors in military operations. The Americans had recognized a fundamental truth about industrial warfare. Abundance itself was a weapon, perhaps the most devastating weapon in the entire arsenal. Fujimoto watched his own government struggle with resource allocation decisions that the Americans seemed to bypass entirely through sheer material surfeit. Japanese military planners held agonizing debates about whether to allocate limited steel production toward warship construction or aircraft manufacturing or tank production. Every ton committed to one use representing a ton unavailable for equally critical alternatives. Meanwhile, American industry simply scaled up production across all categories simultaneously, adding factory capacity faster than Japanese intelligence could track it. Liberty ships sliding into the Pacific at rates of 3 per day. Aircraft rolling off assembly lines in numbers that Japanese reports initially dismissed as impossible exaggeration. Steel production figures that exceeded pre-war Japanese annual output in single months. The symbolic object that haunted Fujimoto's analysis was not a weapon, but a tool: the American bulldozer. Japanese forces used human labor for earth-moving operations, sometimes mechanized equipment when fuel supplies permitted, but always with careful calculation about whether the fuel cost justified the time savings. American construction battalions deployed bulldozers as casually as Japanese forces deployed shovels, earth-moving machinery in such abundance that mechanical excavation was simply the default approach to any engineering challenge. Those bulldozers appeared in reconnaissance photographs everywhere American forces established forward positions, scraping airfield surfaces smooth, pushing coral into reef gaps to create protected harbors. The bulldozers represented something more than equipment superiority. They embodied an entire philosophical approach to problem-solving through applied industrial power. Where Japanese engineers might survey a construction challenge and calculate the minimum resources needed to achieve the objective, American engineers seemed to ask a different question. What's the fastest possible completion timeline if resources are not the limiting constraint? This inversion of priorities, treating time as the precious resource and materials as abundant, made sense only in an economy of overwhelming productive surplus. Japan was fighting an industrial war with a resource-constrained island economy. America was fighting the same war with a continental industrial base that treated steel and fuel and concrete the way a forest treats wood, as renewable resources available in effectively unlimited quantities once proper extraction systems were in place. By mid-1943, the evidence had become overwhelming and undeniable. American construction capabilities were not just superior to Japanese estimates. They existed in a different category entirely, operating according to different rules about what was industrially possible. Henderson Field on Guadalcanal, bombed more than any other airfield in the Pacific Theater, never remained closed longer than a few hours. American engineers had stopped even attempting permanent repairs, instead maintaining stockpiles of Marston matting sufficient to resurface the entire runway multiple times. Bomb craters became almost routine inconveniences, potholes to be filled and covered during regular maintenance cycles, rather than strategic damage requiring careful restoration. Fujimoto wrote detailed reports about what he was observing, submitting them through proper channels with increasing urgency. He documented repair timelines, estimated American construction battalion sizes based on photographic evidence, calculated probable logistics pipeline capacities needed to support observed building rates. His conclusions were professionally devastating. Japanese military strategy in the Pacific was predicated on assumptions about American industrial capabilities that had been catastrophically wrong from the beginning. The sleeping giant had not merely awakened, it had been stronger asleep than Japanese planners had imagined possible when fully roused. Most of his reports vanished into the military bureaucracy without response or acknowledgement. The ones that did receive official reply came back with polite suggestions that Lieutenant Commander Fujimoto was suffering from tropical stress, or perhaps excessive exposure to enemy propaganda. His superiors found it easier to dismiss his analysis than to accept its implications. To acknowledge that American engineering capabilities exceeded Japanese projections by orders of magnitude meant acknowledging that the entire strategic framework for Pacific War was built on false premises. It meant confronting the possibility that Japan had entered a conflict it could not win through any amount of spiritual discipline or tactical brilliance or individual sacrifice. It meant accepting that material abundance, the very thing Japanese military culture dismissed as spiritual weakness, might be a more decisive factor in industrial warfare than Bushido or fighting spirit or willingness to die for the emperor. The transformation in Fujimoto's thinking occurred gradually but irreversibly. He had been raised in a culture that celebrated austerity and sacrifice, that found virtue in doing more with less, that treated material want as a crucible for spiritual strengthening. He had internalized the belief that Japanese industrial efficiency, extracting maximum output from limited inputs through superior organization and discipline, represented a higher form of engineering than Western wasteful abundance. But the evidence accumulating in his reconnaissance photographs told a different story. The Americans were not suffering from industrial incompetence or lack of discipline. They had simply solved the resource constraint problem through such massive overproduction that constraints effectively ceased to exist at operational timescales. There was an almost Zen quality to the realization, though Fujimoto would never have framed it in those terms in official reports. Japanese military culture stressed mastery through limitation. The swordmaker who folds steel 10,000 times to achieve perfect hardness, the archer who practices single-shot placement for years, the gardener who achieves beauty through precise minimalism. American industrial culture seemed to embrace a different philosophy entirely. Mastery through abundance, through creating systems so productive that individual failures became statistically insignificable, through solving problems by overwhelming them with material excess. A Japanese engineer might spend weeks carefully repairing a single damaged section of runway to perfect specifications. An American construction battalion would simply bury the problem under tons of prefabricated steel matting and move on to the next task. Neither approach was inherently superior in abstract engineering terms. In a resource-constrained environment, Japanese methods represented optimal efficiency. But the Pacific War was not being fought in a resource-constrained environment, at least not for the Americans. They had access to effectively unlimited steel, effectively unlimited fuel, effectively unlimited labor, effectively unlimited industrial capacity. In that context, efficiency ceased to be a meaningful metric. Speed became the only variable that mattered, and speed was achieved not through clever resource management, but through brute force application of overwhelming material superiority. The symbolism of rebuilt airfields extended into every aspect of the Pacific Campaign. Japanese soldiers learned to view American logistics infrastructure with something approaching superstitious dread, the way medieval armies might have regarded enemy forces that seemed to conjure food and weapons from thin air. Captured supply depots revealed stockpiles so extensive that Japanese forces, accustomed to operating on razor-thin margins, initially assumed they had discovered strategic reserves meant to supply entire army groups. These were simply normal American forward position supply buffers, standard logistical practice for units that expected reliable resupply within days rather than weeks or months. The food particularly haunted Japanese soldiers' imaginations. Not just adequate rations but abundant variety, meals prepared with attention to palatability rather than mere caloric sufficiency. American field kitchens served hot breakfasts with eggs and bacon, coffee in seemingly unlimited quantities, fresh bread daily, vegetables preserved through canning technologies that kept them recognizable as food rather than reducing them to gray paste. Japanese soldiers subsisting on rice and pickled vegetables and occasional fish, their supply lines attenuated to breaking points, could scarcely process the casual abundance with which American forces approached field rations. This was not a reflection of moral superiority or inherent worth. Japanese soldiers were not less deserving of adequate food. It was simply an expression of industrial capacity. American agriculture and food processing and distribution networks operated at scales that could support this abundance, even for military forces deployed thousands of miles from home. Fujimoto found himself thinking about a conversation he'd had with an American engineering officer, a prisoner captured during early fighting on Guadalcanal. The man had spoken about his civilian career building highways in California, about state government budgets that allocated millions of dollars for single bridge projects, about construction companies that owned hundreds of bulldozers and excavators and cement mixers. He had described this not as exceptional luxury, but as normal commercial operation, the baseline reality of American infrastructure development. Fujimoto had listened with the polite skepticism of a man hearing implausible travelers' tales. But the reconnaissance photographs validated every word. The Americans were approaching military engineering the same way they approached civilian construction, with overwhelming equipment availability, standardized procedures, and an assumption that material resources existed to be used rather than carefully hoarded. By late 1943, Japanese forces had begun adapting tactics to account for American airfield repair capabilities. Bombing raids shifted from attempting permanent destruction toward disruption timing, trying to catch enemy aircraft on the ground during maintenance windows, targeting fuel and ammunition dumps rather than runways themselves, accepting that crater damage would be repaired within hours and planning accordingly. This represented a fundamental strategic retreat, an acknowledgement that Japanese air power could not achieve the kind of lasting infrastructure damage that doctrine had assumed possible. The Americans had rendered a significant component of Japanese tactical planning obsolete simply by being able to rebuild faster than the enemy could destroy. The epilogue of Fujimoto's story unfolded in the final years of the war, as American forces island-hopped across the Pacific with methodical inevitability. Each captured island followed the same pattern: initial assault, rapid airfield construction or repair, immediate establishment of extensive logistics infrastructure, progressive buildup of military capacity until the position could support offensive operations against the next objective. Japanese defenders watched this industrial ballet repeat itself with variations but fundamental consistency, like watching the same machinery produce identical products at different factory sites. Fujimoto survived the war, returned to Japan, and found his engineering expertise valued in post-war reconstruction. He helped rebuild infrastructure in cities reduced to rubble by American firebombing, applied lessons learned from studying American construction techniques to accelerate Japanese recovery efforts. He never spoke publicly about his wartime intelligence work, but in private papers discovered after his death in 1987, he had written extensively about what he called the lesson of the airfields. That industrial capacity in modern warfare was not merely about producing more weapons, but about creating systems so abundantly productive that traditional concepts of resource limitation ceased to apply. He had observed firsthand the collision between Japanese efficiency culture and American abundance culture, and had recognized that, in the specific context of mid-20th century industrial warfare, abundance represented a kind of technological judo, turning material excess itself into a weapon that enemy efficiency could not counter. The rebuilt airfield stood as monuments to a larger truth about democratic industrialism that Japanese military planners had fatally misunderstood. They had assumed that democracy's messy decision-making processes and profit-driven civilian economy would handicap America's ability to mobilize for total war. They had failed to recognize that the same systems that produced abundant consumer goods in peacetime could rapidly retool to produce abundant military materials in wartime. That civilian engineering expertise transferred seamlessly to military applications. That democratic governance's tolerance for dissent and debate did not preclude decisive collective action once consensus emerged. The Japanese military had correctly identified American society's love of comfort and material abundance. They had simply misinterpreted this as weakness, rather than recognizing it as evidence of industrial capacity, so vast it could afford both butter and guns simultaneously, both battlefield necessities and creature comforts, both present consumption and future investment. The airfields that reopened overnight were not miracles or propaganda exaggerations. They were industrial policy made manifest in steel and coral and crushed stone, expressions of an economy that had solved the production problem so thoroughly that questions about resource allocation largely reduced to logistics timelines rather than absolute constraints. They were evidence that some nations could literally afford to bury problems under tons of prefabricated solutions, to treat infrastructure damage as temporary inconvenience rather than strategic catastrophe, to operate on the assumption that for every destroyed resource, two more could be created and shipped forward within days. Lieutenant Commander Fujimoto's notebooks, preserved in Japanese military archives, contained sketches of Marston mat configurations, calculations about American construction battalion sizes, reconnaissance photograph annotations documenting repair timelines. They represent the work of a professional trying to comprehend an industrial reality that invalidated his training and experience. His most frequently recorded observation, appearing in various formulations throughout the notebooks: they do not repair what we destroy. They simply produce more than we can destroy. The mathematics are unsolvable. The sun sets over Shortland Islands in 1945. Same tropical heaviness as the dawn 4 years earlier, but the equation has shifted completely. American airfields dot the Pacific like stars in an industrial constellation, each one a node in a logistics network that flows with such abundance that individual interdictions achieve nothing lasting. The calculations that made sense in January 1942 have been rendered quaint by the sheer industrial momentum of a nation that approached wartime production the same way it approached peacetime consumption, with the confident assumption that material resources existed to be used rather than carefully rationed. The airfields that refused to stay destroyed had whispered a truth that Japanese military culture struggled to process: that abundance itself could be discipline, that plenty could be strategy, that the ability to build faster than the enemy could destroy represented not wasteful excess, but possibly the most devastating form of warfare yet conceived: industrial attrition in which one side possessed effectively infinite industrial reserves, while the other operated on margins so thin that every loss compounded irreversibly. The legacy endures in military engineering doctrine studied worldwide. Speed of infrastructure repair can be as strategically valuable as initial construction durability. Logistics abundance can compensate for tactical disadvantages. Prefabricated standardized solutions can outperform custom-engineered responses when time rather than materials represents the critical constraint.